Hi, welcome to the first exercise of Maths and Tricks. Today I will show you an example of bisection method. But before going to do this, let's see the graphical representation. Well, bisection means to divide anything into two equal parts. Here we divide the range from point A to point B through point P and to two equal parts. And to know what portion should I select for the next iteration, you need to check out the function sign at point P and at point A. If the sign is opposite, so replace point B of the next iteration with point P, which would mean the range with opposite sign of the function, putting these two endpoints. This is to be repeated for each and every iteration. Make sure that the sign of the function at the endpoints of your range is opposite, because if it is the same sign, you will escape the root. So repeat the iterations, so on until the difference between point A and B nearly equal to 0. In other words, the range becomes extremely smaller. Okay, the example which I'm showing you is from the reference book. It's e raised to the power x minus x squared plus 3x minus 2. For instance, this is in a function, any function of x. The range of x is from 0 to 1. 0 is point A and 1 is point B. I called A naught and B naught because it's the initial values, where P is the average of these 2 points. Now to find the actual solution, grab on your calculator and write down the function. After writing the function, press key shift and then Cal C in order to solve it. It will ask for a value of x. Enter any value that lies between this range. The most suitable is 0.5. You get the actual solution, which is 0.25753 Now that's the actual solutions. Now to find the same root using numerical iterations, the best way to do it is to make a table including point A, B and P. Also function at x and at A. Take your calculator again, write the function for point P, which is the average of the two extreme points, and when I press Cal C after writing the equation, it will ask me value of A, in this case it's 0, and press equal, then B, the value of B is 1, we got point P. And then go back to your original equation, press Cal C, it will ask you for a value of x, press ans, the original value is stored, which is the value of P, that's 0.5. It will give you the value of the function at point P, 0.89872127, which is positive. And the things to be noted is that the value is positive, while the function value at A is negative. So it's opposite in sign. We need to select that range and need to replace point B for the next iteration with point B of the previous iteration. And we got new range from 0 to 0.5. And going back again into the average equation, press Cal C, value of A, which is 0, value of B, now it's 0.5, you got P, which is 0.25. Go back to your original equation, press Cal C, it will ask you for the value of x, press ans, previous value of B, 0.25, it gives you f of x minus 0.02847,458. The things to be noted is that it's negative in nature. So both is negative, we need to replace point A for the next iteration with point P of the previous iteration, which becomes 0.25. And the range becomes from 0.25 to 0.5. So repeat the iteration until you get the range small enough. So your job is to complete the table. And now let me jump into the 10th iterations. The value of A is 0.2562344. Well, the value of point B is 0.257125, and the average of these two is 0.2566796. And the value of function Rx minus 0.003214385, and is the value of function 8 is negative again. So the root, which is approximate, not the exact, its 10th iteration, P10, is the average of A and B, its 10th iteration, and it is 0.256679685, which is very close to the exact root, that is 0.2575303. So that's the way it is. Hoping it was helpful. Thanks for watching.